proszę Państwa, Jagoda.
Okay, who is this terminal? Yeah, and who likes cheese? Yeah, of course. So I have something for you then. I will talk about Ratatouille and porting it beyond the terminal. Yeah, so. Oh, 2 minutes. Okay, but what is Ratatouille?
Can you use something apologetic?
Yeah. So what is Ratatouille? Well, if you seen the movie, you would know it's all about cooking, and well, the movie doesn't mention the other part that it's also about cooking the terminal user interfaces. So here's a demo of its capabilities. As you can see, we can use many different widgets, and it basically all makes graphical user interfaces obsolete. Yeah. So you probably used top or htop, and now we have bottom, which is written in Rust using Ratatouille. Yeah, also it of course supports even the mouse input, and yeah. Oh, and one thing. Codex is right now, OpenAI is right now rewriting Codex CLI tool in Rust, and they also use Ratatouille. So this interface was written using Ratatouille. Yeah, and like you can have even fractals in your terminal if you ever needed that. Yeah. And yeah, this was also made using Ratatouille. Yeah, so now you know what Ratatouille is, but well, in my opinion, Ratatouille is its community, and the community is pushing terminal user interfaces to the limits, really. You probably heard about Bevy, the game engine in Rust. Yeah, so yeah, this renders in the terminal using Bevy Ratatouille camera. And yeah, as you can see, you can even, like shadows work. And you can even have the 2D Ratatouille widgets in this 3D space.
Does it support ray tracing?
I think Bevy does not yet, but it's coming.
Yeah, this is great. We can, like, all we ever wanted was games in terminals, right? So now we can have like real 3D games in terminal. Like, yeah, I think this is pretty cool. And also, you can have like DVD logo bouncing in your terminal, because yeah, Bevy Ratatouille camera handles both 3D and 2D renderer, so yeah, you can do stuff like this. Or I don't know what else there is. TTs. I think it. Oh, like a maze in 3D. And by the way, this runs smooth, right? We can also have like effects, like you can see the fade in, fade out, using Tachyon FX library. Like, yeah. Who needs graphical user interfaces if we have stuff like this? It looks better and it's in terminal, so.
Does it work over SSH?
It should work. And next.
Does it play the difference in which terminal you're running this?
I mean, it depends on what features you are using. So it's basically this. So if you need the feature, if you are using in your terminal UI a feature that requires some kind of emulator, then yeah, you will be limiting it. But yeah. Okay, so what if I told you that we can bring terminal UI beyond the terminal? Because Ratatouille has 3 built-in backends that use different terminal manipulation libraries, cross-term terminal and term-piece. But I can maybe the font bigger. Yeah, but it also exposes the backend trait, so you can create your own backends that can draw to anything you want. So it doesn't have to run in the terminal, actually. So I will showcase a few of these. So the first one is soft ratatouille, and it's a terminal. It skips the terminal emulator and draws directly to basically in any pixel buffer. So, for example, yeah, it opened on the other screen, of course. Yes, so as you can see, you can, for example, render to a texture and, for example, use that texture in Bevy. So we can have the exact opposite of what Bevy Ratatouille camera does. And yeah, maybe it's just a cube rotating, but like think what it enables, because we now can have like a game where we have a computer screen, and on this computer screen we can run application written in Ratatouille, using Ratatouille. So I think it's pretty cool. And
does it emulate like real terminal underneath?
No, there's no real terminal. It's just because
It runs Ratatouille application just.
Yeah, just uses different backend, not the backend that uses terminal manipulation, but yeah, to the pixel buffer. So it loads font also and so on.
But
Yeah.
it still technically like composes the UI out of characters, right? It doesn't.
Yes, yes, yes,
Okay.
yes.
But because this uses the terminal rendering, it gives us characters. But the other backend composes a texture itself, right? It does.
Yes, yes, yes.
Font, all this kind of stuff.
So yeah, so Ratatouille provides, for example, characters and where they should be in the terminal, and this just creates a pixel buffer and takes like character by character and puts this in the coordinates it should be. Yeah. And yeah, the other backend is Ratatouille vGPU. And actually it's a, Actually, it's a very similar concept. So it also can draw to any buffer, any pixel buffer. So it, for example, can draw on a in our browser. But the difference is that Ratatouille vGPU uses GPU acceleration, and the soft Ratatouille is pure software. So yeah, it will load for a while. But it also has a very big potential in, for example, games. Yeah, and any minute now, I swear. Wow, I don't know. Oh, yeah, it works. So we have a text editor. Yeah, so we can, for example, like, I don't know. Yeah, and yeah, it's made using Ratatouille. So it's really cool how portable this little framework is.
Have a question?
Yeah. Do you know the reason why it loaded for so long?
I don't know. It wasn't created by me, so,
Okay.
but
Okay.
But it's not
I-
really
I-
by any means. It perhaps the poor network connectivity here.
Okay.
Because typically it's just inconsistent.
yeah. So also there's a UEFI backend. So we can write like bootloader using Ratatouille. This uses nightly Rust, by the way, because Ratatouille currently uses standard library, but the next release of Ratatouille will be No-std compatible. So there's actually a pull request open, No-std support, because we already released an alpha version with No-std support, but I will talk about it in a minute. Yeah, so yeah, so I was at FOSDEM in Brussels this year, and basically that's how I learned about Ratatouille. And yeah, so Orhun Parmaksis gave a talk about Ratzilla, which is his own backend for the web. It's really cool, and yeah, that's pretty fast. Like there's animation running like instantly. Anyway,
Sorry, can I take a question?
Yeah.
What is the difference between this and the first thing which you showed?
Yeah, so Ratzilla is, I think it's the purpose. So Ratzilla is made exactly to use in the web and has, in fact, like, as I remember correctly, 2 different backends. For example, because the previous one only rendered to pixel buffer, and Ratzilla can also create a whole DOM. So it can compose it using real characters and like span elements, so on, and yeah. Yeah, and he basically showed this, and I at this point started to wonder, like, where else can this run? Because having the possibility of implement of your own backend is pretty crazy. So yeah, no, I have pretty crazy setup, by the way. Don't worry. Yeah, so fast forward 1 month later, I was organizing Rust Meet, which was the first Rust conference in Poland. And we had this idea to give away SP32 dev boards to all participants. And we also wanted to make a Rust program on it. And it was pretty crazy, and I'm really happy that we managed to pull it off, because I was writing the embedded code for this and never touched embedded Rust before. So yeah, that's the device we gave away. That's what we came up with. So we were able to send messages or questions to it through MQTT. And yeah, you could, like, with one button choose the answer, and with the other confirm it. So we were using it to send messages, also to rate the lectures, and in the end we made a quiz using it, and it all worked. Yeah, it was untested with real people. It was like, yeah, I'm really happy it worked, actually.
It just works.
Yeah, that's how software should be, right?
I'm sorry, I missed a question. Because you said we were able to send questions. Do you mean the speakers, or anyone could come up and send questions?
No. We were sending questions, as in, for example, here, after each lectures, and then collecting this, and at the end we used it to make a quiz. So we sent a question, like, collected the answers, and so on, so on. Yeah. And by the way, yeah, and one more thing, because basically we invited Orhun to present Ratzilla on Rust Meet, and I think that was the moment I thought, wait, what if I tried to run Ratatouille on SP32? And one more thing, because I wasn't the first one to try to run Ratatouille on SP32, because Plule managed to run Ratatouille on Minitel, French terminal, using SP32 to send the data through serial to the Minitel. It's really cool project, and if you like retro computing, you should check it out. There's a link here, but I will also link all different projects on the end slide. So, yeah, so creating a custom backend is actually pretty simple. You just need to implement the backend trait, and it's just few methods you would expect to be there. So nothing crazy here, like draw, which gives you an iterator over cells in the terminal. So you just go through this and render each character. There are methods to show and hide cursor, to get or set cursor, like clearing, getting the size of the window, and flashing. So yeah, everything you would normally expect from this. And okay, so I'm implementing the backend trait, but what do I actually draw to? So the answer is embedded graphics. It's a graphics library for, well, embedded devices, as the name suggests. And yeah, so I made my first proof of concept version of this backend. I called it Mousefood, because the name idea was like to sound like ratatui ripoff, because it's cheap on a cheap device. And it was far from perfect, as you can see, but it worked, and the dopamine hit was enough to keep me going. So it's hard to see here, but well, the first problem I had to solve was the Unicode support, because Ratatouille extensively uses, for example, box drawing characters or Braille, but it's hard to see here, but you get the idea, the dots. And yeah, so Ratatouille uses it a lot to create pretty looking widgets. And yeah, so yeah, and so the built-in fonts in embedded graphics are very light. So it's literally just this, just ASCII. And that's understandable, because they are designed to fit on a microcontroller, but the ESP32 can fit more, and well, we needed more. And as you've seen before on this slide, I actually had borders working here. And it's because I didn't use this one in the first version of Mousefood, but I used this, IBM 437. So it has some more characters, and that's basically how I was able to draw borders, because you can see there are some border characters. But it's still not enough for most widgets, so I had to find a better solution. As you can see here, there are question marks. A lot of, yeah, so it wasn't enough. So yeah, I found a BDF project in Embedded Graphics Organization on GitHub, and it's still under development, but it lets you convert BDF fonts to embedded graphics fonts. Embedded graphic fonts are basically a raw data plus some Rust code that converts like characters to the position in that raw data. And it wasn't quite working because, as I said, it's still under development, but I still was able to use it. I just had to, after the generation, I had to manually change some stuff, but eventually it worked. And well, I just needed a font to use for that. And well, it's hard to see. Just imagine there are a lot of characters here. And that's all I wanted to show about this, because the first obvious idea was to use Cosette. It's the font I'm using in this presentation, by the way. It's pretty much the best bitmap monospaced font out there, but it's designed for the desktop, so it's a lot of characters, and they are a bit too large than what I wanted, because I'm also dealing with quite small screen resolutions, and bigger fonts, bigger characters mean that I have much less space to draw anything. So I decided to check what embedded graphics uses, and well, embedded graphics uses Xorg font collection that is literally named miscellaneous, and it's public domain, and no one knows who made it, which is it's pretty funny, but yeah, and it was what I needed, and so I just regenerated this, the exact font that embedded graphics used, but just without limiting the character set to ASCII. So I ended up with this. You can see the small dots. These are characters. it's enough. And yeah, so the next problem I had to solve was buffer flashing inconsistencies, because some display drivers write directly to this display, and this is intended way for embedded graphics. Embedded graphics tries to be the library. Tries to be a graphics library that doesn't use any buffers and writes directly to the screen. But some drivers implementing embedded graphics still use a built-in buffer. And that's problematic, because if they use a built-in buffer, that there must be some kind of way to flash this buffer. But since, well, embedded graphics doesn't provide any traits for built-in buffers, then they just use just methods they came up with. So you flash buffer basically different way on every one of these drivers. So it's not that great. And I fixed that by in 0.2 version of Mousefood by introducing a flash callback. So you can just provide a closure how this should be flashed, and yeah, but we are now working on a better solution using separate driver integration crates. So you can just add that driver integration crate to your project, and it would be just plug and play. So it will be much easier. And also it fixes the problem, because I also had to implement buffer in Mousefood. But since some of the drivers already use buffers, then I had like 2 buffers. And yeah, so this integration crates now implement buffers if they are missing, and not implement them if they are already there. So yeah, but it's the future. That's the next version. But yeah, so demos. As you can see, it runs pretty smoothly. I actually have some of these devices. I can show this later to you. And yeah, it also runs on e-paper. And yeah, here's a setup of Deadbed, who's a contributor to the project. And here's a project made by Orhun, actually, who made a guitar tuner called Tuitar, because, you know, terminal user interface, Tuitar. Yeah, and I mean, this project started like can I do this? I didn't think much about any real use cases, but use cases just appeared out of nowhere. And okay, now it's time for a few words about the standard library and No-std attribute. So by default, every new project links to std crate. And std includes and re-exports contents of core and alloc. And also some other stuff that is present only in the std. But the core is the most fundamental part of Rust standard library. It includes all the primitive types. It also includes many traits that are, yeah, I think it's like a glue between the language and the ecosystem. Yeah, and also the alloc crate, on the other hand, adds dynamic allocation related traits and implementation, because, for example, pointer types or collections like vector or string, because these only work if we have heap. And yeah, I will get back to that later. But yeah, and the rest of standard library is basically the platform-specific abstraction of platform-specific stuff, because the core is basically in pure Rust. Yeah. And here are, for example, threads, and much more on that later. And yeah, but so adding No-std attributes makes your project link to core instead of std. And this means that we have no OS-dependent functionalities, no like file system, no printing, because we don't have standard output, because std out, it even has std in name. Yeah, so there's no threading or TLS, and no heap, no way to make dynamic allocations. But why even bother then? Well, if you create your crate to be No-std compatible, then it can basically run on almost anything. For example, microcontrollers. Yeah, and how did I run Ratatouille on SP32 if it requires standard library? Well, there's a very interesting alternative hardware abstraction layer that is a community effort for SP32. You have to install a custom toolchain, so it basically is a fork of Rust, but it allows you to use standard library on SP32, which is really crazy. It, for example, maps std thread to free RTOS tasks, and this way you can use threads from standard library like you would normally use. And yes, you can use Tokyo on SP32 using this hardware abstraction layer and the custom target, which is really crazy. And Yeah. So I had Ratatouille running on SP32. That's great, but why should I stop there? So I analyzed the Ratatouille code base to find what would need to be done to make it No-std compatible. And I proposed the changes to the core team, and since it seemed doable, we just went for it. And as you can see, yeah, it was quite a lot of PRs in the end, but I think the implementation is, what we came up with is pretty great. And yeah. So how you do so how do you make your crate No-std compatible? So first of all, we had to link to alloc crate because we still needed allocation, because it would be pretty hard to change Ratatouille to not dynamically allocate memory at all, and we can still link to alloc anyway. The next thing was to, as I said, the standard library is re-exporting a lot from core and alloc, so we had to change std to core and alloc in our imports. We also added linter rules to use core or alloc instead of std. We also made it easy to disable std features in upstream crates, because it's a lot of crates are actually No-std compatible, but they have like a std feature flag that is turned on most of them by default. So you have to disable default features, and we also, since we still will be using Ratatouille on the terminal most of the time, then we still need this std feature, and we just enable std also in all the upstream crates. We also used hash brown for drop in No-std hash map replacement, because hash maps are only in std, so we couldn't use that. But yeah, this is drop-in replacement, and also a bit faster than, as I remember correctly, than the implementation in standard library. So we also switched from cassowary crate. By the way, it's a crate to compute layout constraints, but it's unmaintained for many years now. So we forked that, cleaned it up a bit, and also introduced No-std to it, compatibility to it, and we used that. We also had to add some additional feature flags. I will talk about layout cache later, but yeah, if some feature needs std, then we already have the std feature, and just put it in there. And finally, we had to make the crate No-std compatible by adding the No-std attribute. And yeah, since we have the std feature, we can just link to std anyway using conditional compilation. Yeah, so now we had to make changes to the upstream crate, so cassowary, which we forked, which is our fork. The changes were pretty straightforward there. So it's just std to core and alloc, No-std attribute, linking allocrate, hash brown, and disabling. I think it was only this error in here that has STD enabled by default, so it had to be disabled. And also line clipping, which literally just required adding no-std attribute. It already worked. And
Can I have a question? I lost, like, why do you even replace std, right? And you use, like, let's say you have hash map in std, and you replace it by some other hash map. But why std was removed at the first place?
yeah, STD was removed. I mean, it wasn't removed entirely, but because, for example, as you can see here, we are linking to it by default anyway.
Yeah.
We just wanted to make it possible to run it without STD, but also doesn't work with the terminal backends because they use terminal and we can't have that. So the terminals, terminal backends that are built in to Ratatouille still use STD, but the core and widgets and so on are no STD compatible. So we can still use that by implementing our custom backend like Mousefood. We can use that to run on almost anything. By the way, like a few hours before the meetup, I got like a video from Orhun that he actually made it run on PlayStation Portable using Mousefood. And because I already have it's not released yet, but on the repository on main, Mousefood is already now STD compatible because we have the alpha release of Ratatouille. And yeah, he made it run on PlayStation Portable, which wouldn't work with standard library, but because there is no support of it. Yeah, and yeah, that was yeah. So previously, previously the backend trait used IO error for error handling, but we couldn't use IO in no-std. So we introduced an associated error type to backend trait, and then in the standard terminal backends, we still used std IO error. So it's still backwards compatible as long as you are using the built-in backends. But if you are making custom backends, then you can put any your own type there, making it no-std compatible. Yeah, the most CPU expensive part of Ratatouille is computing layouts from the constraints, and it's pretty heavy if you have like a big table and it has to be all constraints have to be computed in each frame. Then, so to not make that, we use a layout cache, which is a thread local least recently used cache. But it's a problem because thread local, as name suggests, uses threads, and we don't have threads in STD, in no-std, because it's only in the STD. So, well, I experimented a bit with implementation using critical section and one cell. It's not perfect. In fact, it's terrible, and we didn't use that in the end because it pulls 2 additional dependencies, no matter if you use this or not. And also it's, since we use mutex, it's locking. And so for now, in No-std, there is no layout cache. But it's still fine because it only really matters for complicated layouts. So yeah, maybe we will add a better alternative solution in No-std later on, but for now, you just have to turn off the layout cache feature flag, and it will be No-std compatible. That's why, as I showed here, layout cache depends on std feature flag feature. Yeah, and I mentioned earlier that the core includes primitive types, but it's not entirely true when it comes to methods of this. Some are missing. For example, trigonometric functions in F64. And yeah, my initial idea was to create a new polyfills crate. That's, of course, a simplified version of this, but yeah, it just implements all the missing functions in F64, and it used libm, which is math implementations in pure Rust. So basically soft float stuff. So it's slow. And how can we make it faster? Well, we don't need that much precision. So yeah, because of that and because of the fact we don't want another dependency that most of people won't use, we just implemented polyfills inside Ratatouille. It was just few, I think it was like 4 methods that we actually needed. Cosine, sine, I think it was rounding, and bool add. And it was all we needed, so it's pretty short. And for trigonometric functions, we used approximation implementation from micromath crate. And it's precise enough because it's only used to basically draw circles in the terminal using the characters, so it doesn't have to be that precise. It will still pass the previous tests. Yeah, and you use this, you use this like this, so you just pull this trait into the scope, and you can just use cosine on F64, no matter if it's standard library, with standard library or without, so it's great. Yeah, and well, as you can see, Ratatouille is right now No-std compatible, at least in alpha version. So we have Ratatouille, Ratatouille core, Ratatouille widget, Ratatouille macros. They are all No-std compatible with a lot of features too. And what's next? We are releasing Ratatouille 0.30 soon, and Mousefood will follow soon after. And it's gonna be a pretty large update with modularization, because yeah, we are breaking the single Ratatouille crate into Ratatouille core, widgets, all the backend integrations with different terminal manipulation libraries will be different crates. and so on. And yeah, and there will be much improved documentation. We want to make Ratatouille as easy to use as possible and as easy for people to get into that as possible. Yeah, and yeah, we also launched Rat in the Wild challenge. So if you want to, like Orhun did, run Ratatouille on PSP, if you want to run, I don't know on what you can run Ratatouille, Nintendo 3DS. Yeah, just go for it. And yeah, you can win a cooking apron because it's all about cooking, as I said in the beginning. Yeah, and it will be everything. If you want to see some of the projects I showed before, then here are all the authors and projects. And
do you have some access to it, or should I take a photo?
yeah, I mean, if you want to take a photo of this. And I will show QR code of other things later, but I just couldn't make QR code for all of this. So if you want to take a photo, then
I will try to share the materials, maybe presentation or some. There will be video from this meeting.
I'm happy to show the slides.
Yeah, cool.
yeah, and here Ratatouille Mousefood and the Rat in the Wild challenge QR codes. I didn't change the title on the last. I added this slide like right before right before presenting. Okay, that's all. Thank you.